Alright, this is your Quiz 7 study guide, and we're on the 8th of October. So, matrices that we talked about on Monday. Multiple choice, identify the choice that best completes the statement. What is element 2, 3? 2, 3, that's row 2, column 3. Row 2, column 3. That's a -7. So in this case, we've got two -7s here. Let's go with answer choice A in this case. Hopefully it won't happen on your quiz. If it does, just be sure that you email me or see me in class after the fact. Element A, 12, is row 1, column 2. So row 1 is right here. Column 2 is right here. And that is a +2. Answer choice C. Unfortunately, the study guide has the answer as A, so that is incorrect. How can you represent the system of equations with a matrix? Okay, remember, this would be represented by, this first equation would be a 15, a -15, a line for the equal sign, and then a 4, closed bracket. And then we've got a 15, +2, and a -4, closed bracket. So let's see. Looks like answer choice A here. And number 4, same concept. -11, -15, and a 2. 7, -15, and a 2. So -11, -15, 2, 7, -15, 2. Answer choice A. Alright, it's the same concept here again for number 5 as it was for problems 2 and 3. Or I'm sorry, 3 and 4. So just remember that your corresponding coefficients, they must stay in order. If there's a variable missing, you replace it with a 0. In this case, we got a -4, a -10, a 5, and a 4. 14, -5, -7, 7. And then we get this 10. We get the 14, the 5, and the -5. So obviously it can't be answer B or D because the size of the matrix doesn't match the system of equations. So 4, -10. It looks like they've got some numbers out of order here. Since this up here is a 5 and this is a 7, the best answer in this case, it looks like the computer program has written a 7 in these two locations instead of a 5. But this has your -4 out here, so it can't be A. So it's going to be answer C. Alright, number 6 is the same thing in reverse. I'm just going to write these out. I'm going to use X and Y, so In this case, this matrix would represent 9x minus 11y equals negative 2, and then negative 14x plus 11y equals 8. So again, match up your best answer. Looks like answer choice C. And again, the same with number 7. We're using x's and y's again, so negative 2x minus 9y equals 11. And then 14x minus 2y equals 15. Alright, what is the solution to the system? This is a review from a couple weeks ago. I'm going to use the elimination method. We've got 2x minus 3y equals negative 21. And we've got negative 3x plus y equals negative 26. I'm going to multiply the bottom equation by 3. So I'm going to have negative 9x plus 3y equals negative 26 times 3, 78. I'm going to rewrite the first equation, 2x minus 3y equals negative 21, and then I'm going to combine the equations. So 2x minus 9x is negative 7x. Your 3y's eliminate, and negative 21 minus 78 negative 99. Divide both sides by negative 7. And let's see what happened here. 2x minus 3y equals negative 21. 3x plus y equals negative 26. 3 times 3 is 9. 3 times 26. That's 78. I rewrote this problem wrong. This is a negative 2x, and this should be a negative 2x, which makes this here it is. Alright, this is negative 11x, which means we're going to divide both sides by negative 11, which gives us x equal to 9. Alright. So we can't be A, we can't be C, our only choice is answer B right here. X is equal to 9. Y must be equal to 1. And then number 9, I'll do it over. This is number 8. Number 9's right here. Negative 4x minus 2y equals 0. S 9x minus 7y equals negative 46. Alright, so I'm going to multiply the top equation by 7. I'm going to try to eliminate the y's, or I'm going to eliminate the y's. So I'm going to multiply the top equation by 7 and get a negative 14. Now I'm going to multiply the bottom equation by 2, negative 2, to get a positive 14. So here's what this will look like. Negative 4x times 7 is negative 28x minus 14y equals 0. And 9x times negative 2, that's negative 18x plus 14y equals negative 46 times, that's a negative 2. 92, negative times a negative is a positive. So 28 and 18, we get negative 46x equals 92. We can divide both sides by negative 46, and x is equal to negative 2. So if we go over here and take a look at our answers, we've only got one x value at negative 2, so answer choice B. Alright, number 10, which is the graph? Alright, based on this vertex form of this equation, the vertex of this graph is at 2, negative 4. Alright? And since this a value is negative, this graph goes down. So we're looking for a vertex that's at 2, negative 4. So 2, negative 4, and it goes down. There's one. This would be 2, 0, so that doesn't work. This graph goes up, so this doesn't work. And this has an x value at negative 2, so this doesn't work. So here's the graph of that quadratic. Alright, the graph of the function. F of x equals 3x squared is the same as f of x equals 3 times x minus 0 squared plus 0. So our vertex would be at 0, 0. Our axis of symmetry would be x equals 0. So then we do a table of values. We put our vertex in the middle of our table of values. We pick 2 points to the right and 2 points to the left. And then we substitute. So when we substitute, I'm going to go back here and substitute. Alright? So if I take 1, replace the x. If x is equal to 1, 1 squared is 1 times 3 is 3. And here if x is equal to 2, 2 squared is 4 times 3 is 12. And this parabola is symmetrical, so our negative 1 would result in a 3, and our negative 2 would result in a 12. So those are your points. If you were to graph this, going 0, 0. We're going 1, 3. And we're going 2 and way up to 12. And then we're going to reflect those. We're going to U-shape the bottom of this graph and connect the dots. Now, number 2 on this study guide here would be done the same way. It's just you're going to square the x and then multiply by 1/4. Just remember that this quadratic is the same as the function of x is equal to 1/4 times x minus 0 squared plus 0. Okay? Those two are the same graphs. Alright, number 3, graph each function. How is each graph a translation of f of x equals x squared? This function here is the same as y equals 1 times x minus 3 squared plus 0. So the vertex of this function is at 3, 0. The vertex of this parent function, we said it the other day that this function is the same as the function of x equals 1 times x minus 0 squared plus 0. The vertex of this function would be 0, 0. So the only two difference in the functions, remember your parent function of f of x equals x squared, vertex is at 0, 0. Here's our function. Here's the graph of our function. Well, if we're comparing this to the parent function and we graph this function, our vertex of this function is at 3, 0. So we would have to go over 1, 2, 3 units and put our vertex. Other than that, everything else is going to be the same. So there's your two graphs. How is each graph a translation of? In this case, graph moves right 3 units. Alright, that's your translation. And that's your two graphs. Alright, for number 4, they ask you to identify the vertex and the axis of symmetry of the graph. So our vertex in this case, -2, -4. Our axis of symmetry is x equals the x value at the vertex, so x equals -2. Alright, problem number 5. We talked about this yesterday in class. Right here, they're looking for a maximum or minimum, the domain, range of the function. So we were identifying more than that yesterday. Let's do the vertex first. This vertex is at -2, -3. So since our A value is positive, this graph right here, number 5, this graph, if we were to graph it, -2, -3, -2, -3 would be down here. There's your vertex of that graph. Its A value is positive, so this thing goes up. If the graph goes up, we said yesterday that it has a minimum value because the vertex is at the bottom of the graph. We said yesterday that the domain would be all real numbers. And in this case, the range would be y. And since the vertex is at the bottom of the graph, all of the y values will be greater than or equal to the y value at the vertex. So -3. So there are your 3 parts to that graph. Alright, number 6, this is a little bit new. Use the vertex form to write the equation of the parabola. What we're going to do right here, first things first, is we're going to identify the vertex. So the vertex of this graph is at -2, 2. Okay. The other thing that we have to identify on this graph is a distinct point. And I see one distinct point and a second distinct point. And this distinct point right here I'm going to use. This distinct point is -3, 5. Now what we have here, since this -2, 2 is the vertex, I'm going to call this H and this K. And then since this is a point on the graph, I'm going to call this X and this Y. And now we're going to write vertex form of a quadratic. Vertex form of a quadratic, Y equals A times X minus H squared plus K. Now we have 4 of these 5 variables. The only thing we don't have is the A. So we're going to solve for it. So where the Y is in this equation, we're going to write a 5. A times. Our X is -3 minus our H, which is -2, squared plus our K, which is +2. Now we're going to solve for A. So 5 is equal to A times -3. We're going to keep change. So we get a -1 in here, squared plus 2. So 5 equals -1 squared is 1. And 1 times A is A plus 2. So we're going to subtract 2 from each side. So we get 3 is equal to A. We've got our 3 equal to A, and we have our H and our K. So we're going to go back to vertex form, and we're going to substitute everything except for the X and the Y. So here's our equation in vertex form of this parabola. We can say that Y is equal to 3 times X plus 2 squared plus 2. Number 7 is the same problem, but you didn't have to find the vertex or a point on the parabola. They're telling you that the vertex is negative 8, 7. They're telling you that it passes through the point negative 7, negative 4. So if we're going to write the equation in parabola form, or I'm sorry, in vertex form, we can go right to this step right here. Alright, here's our h and our k. Here's our x and our y. And we can solve for a. So I'm going to go up here. That negative 4 equals a times negative 7 minus negative 8 squared minus 7. So we're going to keep change in here. So negative 4 equals a times negative 7 plus 8 would be 1 squared minus 7. So if we add 7 to each side, then 3 is equal to 1 squared is 1 times a is 1a, and we write it as a. So here's our a. Here's our vertex. So we can say that the function of x is equal to 3 times x plus 8 squared minus 7. That's our equation in vertex form. Alright, and last but certainly not least, suppose a parabola has an axis of symmetry of x equals 8, a maximum height of 1, and also passes through the point 9, negative 1. So here's an x and here's a y. Remember, the axis of symmetry that we've been talking about all week. Your axis of symmetry in this case is x equals 8. Well, if your axis of symmetry is x equals 8, well then your vertex, the x value at your vertex has to be 8. The maximum height is 1. The maximum height is 1, so the y value at our vertex is 1. And since this thing has a maximum height, it's got to be going down. If it's going down, a has to be negative. So now we have our h and our k, and we've got our x and our y. So we're going to say that y, we're going to go back to our vertex form. We're going to say negative 1 equals a times x minus h. Our x is 9 minus our h, which is 8, squared plus k. And again, we're going to solve for a. So negative 1 equals a times negative, 9 minus 8 is 1, squared plus 1. If we subtract 1 from each side, negative 2 equals 1 squared is 1 times a is 1a, and we don't write the 1. So here's our a value. Which makes sense because a has to be negative because our graph has a maximum height. So now here's our vertex. Here's our a. And here's our equation. Our function of x is equal to negative 2 times x minus 8 squared plus 1. There's your equation in vertex form. I hope this helps. Good luck on your quiz tomorrow. There will be no Zoom meeting or videos for Monday or Tuesday. You will have a handout to complete in class. Please put it in the basket at the front of the room when the bell rings each day. And I'll be back on Wednesday.